All right, well, that's probably a fairly natural place to stop there. We got 15 minutes. It's probably going to be enough to finish off the lab stuff. So when I get a chance, I will try to fix up the calendar and send out an email to tell folks that the date has been changed. By the way, mail still isn't quite working on Legolas. You can, on Legolas, you can now send mail outward to everywhere else, but I got to look up some files at home before I figure out how to get it to forward stuff coming from, say, Aragon or Sam or whatever, and get to the rest of the world. So portions of mail still are not right. I still need to go look at some other configuration files and copy what I have done. Okay, so I think we had stopped around here on page 194. Yeah, if we have time towards the end of the semester, there was also, I did put it in the labs list, something about setting up SendMail and things like that, and a web server. And so I may present a lab that you managed to escape this semester, but I'm not sure how long all this network stuff is going to take. But if we have time for it, I'll look at some other things beyond just what we've seen here and show you some other labs. All right. All right, so recall what we had been doing here. We were fixing up grub so that we could boot our new kernel, or as a fallback, be able to still boot our old kernel if disaster had struck, and so on. And we went to make the default be the new one, the candidate for the new one. So that's what I'm hoping to see when I regrade your. Should still be running the suit at that point. All right. So we went from taking something that worked fine with keyspan to making it break. And then now we put back those capabilities, so with any luck, you should be able to find your keyspan module again now that you've rebuilt things with this new feature. And it's kind of a clunky, fakey way to do that, but it does show you a little bit about how to manipulate the hardware. All right. All right, let's see. All right, yeah, so if we look at these things, all right, I guess I had to do this to see what we've got and what we don't have. After you plug it in, we would hope to find it there, but you should see that it's still not quite this. All right, so misremembered where we were in the labs, right? So now we have presumably successfully removed keyspan and gotten a slightly smaller kernel and a slightly less capable kernel. Doesn't matter whether you plug in that thing or not, it's not going to find your keyspan. All right. So we're at this stage where we've broken the system enough so that we can attempt to fix it. And if you've already done the earlier steps, you know, it takes a long time to compile a kernel and then even longer to compile all the different modules that might be put on there. So this looks like it's going to take a while, but it turns out this time it's going to go quite fast. All right. So all we really have to change here is to say that we really want this thing to be a module. It was not set, that was the default. Didn't have to say anything with that. But now we're going to uncomment it and put equal m to. Now, if you said equal y, that would mean it would bake it into the kernel and would always be there and always on and always taking up RAM space. Since we don't really use these devices, that's kind of a dumb idea. But we can make it a module and have it mount it when we need it. Right, so once again, after you do this, things are not quite working correctly. Right, there would still be no other definitions in here other than this one line. You may recall there are about 20 other things that we needed to set. So if we do the make old config and make prepare pair, that'll put back those other 20 lines to rationalize them for us, so that we don't have to figure out what they were and type them ourselves. Okay. Now, rather than just saying make modules and make absolutely everything, most of which you would find out they're already made, there's no changes and so on. All we have to do is we can give it this extra directive in here. We're going to set a variable called subdirs to be drivers USB serial. And if you look in the make there, what it actually does then is sees that that thing is set. It's either going to be at the top level, in which case it makes everything, or in this case, it's going to go down in here and just try to run the make file that's in this one guy. And that's where that keyspan modules were located. Now, there are also a bunch of other serial things down in there, and it'll try to make all of those too, but it's going to discover on all those other ones, hey, that's up to date, that's up to date, that's up to date. It's only the keyspan guys that were not kernel objects yet. So that's going to happen really fast. It's building a few things, and then it's done. Okay, well, we've got them, kernel objects, but they're not in the right place, and we haven't put all the hooks and whatever into here. So we have to do this make modules install, and again, rather than telling it to install absolutely everything, we can say, hey, just do the ones down in this directory. And it'll say, hey, most of that stuff's installed, but we can then do these other guys. Right, so one of the things that should come along here is that it really is putting in keyspan.ko. Whereas the last time we had done it, when it was undefined, that's not an installation that happened. All right, so with a lock, when you plug it in this time, you should actually get the driver. When you do the diff, you should see things happen. Now, I'm not going to go in there and actually plug it in myself and see if that's all right. So I'm not going to worry too much about whether these guys actually do differ. As long as you've really got the kernel objects in place, I'm okay. So occasionally we have some groups that really can't get it to work again here, and I'm not going to beat you up about that, so that's why I'm all right. All right, so put it someplace where other people can grab it when they need to try this little experiment as well. And then we have just a few unrelated things here. We haven't really tightened up security very much under SUSE. And so we're going to work with PAM again. Right? So underneath the PAM.d thing, similar to the one that we had under Mint, right? We have this one for the SU. And we're going to put in an extra line that isn't there. So find that line and stick this guy down below. So this basically says that you're not allowed to do SU unless you're in the wheel group. And hopefully you've made sure that all you guys are in the wheel group, otherwise you can't do wiggly things So hopefully the answer to that question is obvious. Okay. Now, they do have some startup files. There's a csh.cshrc file. And this is the thing that is sort of like your own .cshrc file in your home directory. But it first runs that one. And then at the bottom of that, it'll run a local version, which often has nothing in it, unless you put something there, like we're going to do. And then it'll run your own CSHRC, and maybe it'll write some of those definitions. And what we did in our CSHRC, you had a CSHRC.sam or CSHRC.aragon or whatever, where you could overwrite some of our standard definitions there and yet again. Okay. All right, so if we do this, it's not the one we want as regular users. It's generally a little bit too liberal, right? It's just turning off write permissions for group and other, but leaving everything else open. So anything that root creates can be executed by anybody, can be read by anybody, and we'll do a chmod if we really wanted it to be a little more restricted. Then in our own CSHRC file, we change the UMasks again. But this will make sure that root, when running as a troot account, never winds up creating files that other people can't read, because usually when root creates a file, we really do want everyone to be able to access it. Or if you create a binary like ctw1 and then install it as root, you want it owned by, seen by everybody, and executable by everybody. Okay. All right, so if we put that change in there again, it only gets run when we first start up the shell, so that any changes we put in there don't happen right away, right? You'd have to source that file or log off and log on again so that it gets sourced as part of the startup procedures. So don't assume it's not working just because your existing shell doesn't know about it yet. It's not supposed to know. All right. So we still have some, if you do an ls-l of some of your home directories or whatever, it's still just listing a bare 1002 there, because it has no clue what group that was, so it just reports the number. Just like you're getting a 666 reported for that beast-owned file and so on. But if we make this change into the group file, then it can figure out what the human readable name for things are, for a few of the things that have been neglected. All right. All right, so since we're trying to tighten up security and make it a little harder to become root here, we know that another way to become root is when Susie says login, you'll just type in root, and you're there. That's bad for keeping track of who's doing what, for example, right? Because you don't know who it was that typed root. It would be much better if they had to first be a regular user and then su to root, because then we have a little log that, hey, such and such person became root just before the system blew up completely. Okay. All right, so if you have a secure device, it won't let you do that. But it does let you do that on your console there, so obviously that's not a secure device. So we can fix that, but you can get to other screens here. If somebody's doing something on one of these screens, they don't really have to log off. You can do something like Alt F3, and it'll give you yet another copy of the console that you can work with. Somebody else can log on there. Alt F1 would take you back to the first person's login, and so there's 6 different ones of those guys that you can work with. And they're all, by default, not marked as secure. So new people coming up on the system can get to be root and fix things if they have problems. But once you're confident you've got things working fairly well, you generally do want to tighten up the security. All right, so go to one of those other consoles, log in there, and do your W thing here and see what actually happens. Right? So you can find out where you're logged on from at any given point. So this is also a SUSE system that we have. And my latest login here, the one where we just did the W, was on sudo terminal S10. But as you can see, I'm logged in a bunch of other places as well, including from my office earlier this week. So where you're logged in gets shown there, and you'll see different things if you log in on those 2 different consoles. You'll see not a pseudo terminal, but an actual, I don't think it's a pseudo terminal, but you'll see a different designation than TTF stuff. Right, so we'll fix this up here to make sure that you can't just become root without it. It's getting harder and harder to become root. So the place where we do that is in this file here, the etc secure TTY, which lists which things are actually secure. So if your console was behind a locked door in somebody's office, you might want to leave it as secure. Someone can get into the office and become root. That's probably the least of your problems if it's not an authorized person. So almost certainly they consider the terminals and stuff down in the machine room we visited last week as secure terminals. And if it's something that's out where anybody can get to it in the library, or anybody can get to it in our lab, it's probably not a good idea to mark that as secure. All right. So there are 6 lines in there that don't already have pound signs in front of them, and they let the Alt F1 guy and Alt F2 guy and whatever all be considered secure. So the pound signs in there make them comments, and now they're not secure. Now, generally, make a change like that, you would figure, okay, there's probably some daemon I have to nudge so that it knows about this change that I just made. But it turns out that the getting program here apparently does just consult that file every single time somebody tries to log on and figure out whether now they're supposed to be allowed in there. So you should find you don't have to nudge anybody. It should keep you from becoming root from the terminal. You've got to log on as a regular person and then SU to root. So if you screwed up the wheel group stuff and you can't SU to root anymore, you have some big problems. You probably have to get the DVD, boot on that, mount this thing, and take out some of those pound signs so that you can become root and fix it. So make sure you're in the wheel group and whatever before you get to the point where you may have locked yourself out. All right. Well, now there's another way to perhaps become root, and that's also open to us on SUSE at the beginning. You can go over to, say, one of your workstations here, and tell it to log in as root. Or if you're already on the workstation, SSH localhost and -L root. And default out of the box, it's going to let you do that at that particular interface. Now, there are other ways to get in. There used to be a telnet command that was horribly insecure and sent passwords in the clear over the network. So did our login and so on. And so most of those things have been shut down. FTP now encrypts your passwords and stuff across. All right, so as we had seen back in Lab 2, what happens with SSH is controlled by the daemons, right? We have a client configuration and a daemon configuration file. We're going to mess with the daemon. That's the guy who answers the request to be allowed to log in. And right now, it's going to say something basically like that. There's a comment in there, and that just tells you what the default is. If you say nothing, and that is a commented thing, the default is to yes, let root log in. So if we want to not allow root to log in, it can't be a comment anymore, so take out the pound and change the yes to no. And again, in this case, SSH doesn't just look at that file every single time somebody tries to SSH over. It really needs to know about the change. So to get it to change, you would do something like that, except last time I tried, they hadn't done this service command well enough in SUSE for it to work. So we would do it basically the old way. You run the little script, fginit.d/sshd, and tell it to restart, and we'll reload its configuration. And I run over, so sorry about that. I'll talk a little bit more about this next time.